let's talk about, yesterday we did average rate of change with graphs. Today we're going to do it in regards to using equations if we don't have the graphs. All right, so today's the 9. Okay, so keep in mind your average rate of change is you're finding the rate for which your output's compared to your input, because that's all slope is a ratio, right? So our ratio is our output over the input, right? That's basically all slope or average rate of change is. Okay. When we're working with functions, we've been doing it all the time as change in y, right? We were doing change in y over change in x. But if we're using a function, then we have to use function notation, okay? And so we calculate it by the change in the function over the change in x, which is the same thing as change in y, just like when we were doing the inverse and we had the function of x, and we had the function of x and we changed it to y to switch the x and y. It's the same thing. So that means we're looking at the change in the output over the change in the input. It's all this exact same thing. We're just using different notation. Okay? And so our slope formula, since we had y2 minus y1 on the top, in function notation, we're going to have the function of b minus the function of a over b minus a. And they're just using different variables. B is like saying x2 and y2. A is like saying x1. Okay, it's just a different notation to show that it's a function. Alrighty, does that make sense so far? Okay, so when we have a function in an equation, okay, we want to calculate the slope over this interval. All right, so what do you need to calculate your slope? Well, basically, you know, your y's and your x's. So we're going to use the formula of the f of b minus the f of a over b minus a. So what the heck is our b and a, right? Well, we're looking at it over this interval, so my a is going to be -2, and my b is going to be 3. So there's the bottom half of the equation, or formula, whatever you want to call it. Everybody with me so far? Yes? Yeah. Oh yeah, -2. Yeah, we'll get to that part in a minute. Yeah, but yes. Okay, now, what is the f of b? Well, my function is 2x squared minus 10, and b is 3. That's like finding the f of 3. So that would give me 2 times 3 squared minus 10. Are you with me? Which is going to give me 2 times 9 minus 10. So 18 minus 10. So the f of 3, or b, is going to be 8. So how do you find what my f of a is? Same thing. Think of it as the f of a for 2x squared minus 10, which means since a is negative 2, I need to find the f of negative 2. Which is going to give me 2 times negative 2 squared minus 10. And negative 2 squared is 4, so I have 2 times 4 minus 10, which gives me 8 minus 10. So the f of negative 2 is negative 2. Should say the f of 3 negative 2. So that means my slope formula is going to be 8 plus 2 over 3 plus 2, which gives me 10/5, which is going to be equal to 2. Good. All right. Let's do, everybody get your graphing calculator out. Let's do it with the graphing calculator. Because this isn't hard. It just takes a little bit of time.
Wouldn't the 2's be negative? Like, wouldn't it be 8 plus negative 2? And 3 plus negative 2?
No, because my formula is minus, so if I'm minusing a negative, then 2 negatives become a positive. Yeah? Okay, so, trying to clear. Okay, there we go. All right, so let's take a look at what we have for A to see if we did it right. So first, and here's your steps, okay? We need to graph the equation. Do you know how to do that? Okay. See this little y equals button? You press that button. Okay, everybody with me? And then enter your function. So I'm going to have, and it already has the y there, so I just have to do 2x squared minus 10. Everybody got that in their calculator? Okay, second step is we're going to use the table function. See how we have a blue table up here? The graph, if we hit the graph button, that will automatically, oops, I have wrong dimensions in here. Thanks for nice time. Let me fix my dimensions, which actually look okay. Good thing we're not doing that one. All right, so if you hit your graph button, then you'll see the graph. But the blue up above is the table. To get that, you hit your blue button. So to find the table, you're going to hit seconds and then graph button. Okay? So I'm going to hit my seconds, graph button. And there's all my values. Oh, they're up here, Bobby, I'm sorry. Okay? And here's a table with all my values. So, to find my rate of change, I can say, okay, what is my x at -2? I'm going to have -2, -2. Oh, look, that's what we found by plugging it in. And then I want to find from 3, that gives me a value of 8. That gives me the same thing as well. And so now I can use my slope formula. Does everybody understand where I've got the table part? Yes, no? All right, so if I want to find the slope from 5 to 9, which method do you want to use? Do you want to use the formula or the calculator? Somebody pick a choice. Isaac, you say calculator? Why is that?
I don't know. Pick ones.
Okay. Let's do it with the calculator. So what are my steps going to be? I need to enter my function, which is the same. So everybody got the function entered in? You hit your y equal button, and then enter your function in. 2x squared minus 10. I wonder why it's not good. All right. Then, so y equals, now I'm going to go to my table, which is the second and graph button. And if I'm looking from 5, what is my y value? 40. And then I want 9. And my y is 152. Okay? And now we can just use, so our average rate of change is going to be 152 minus 40 over 9 minus 5. So 152 over 40 is 112. 9 minus 4, or 5 gives me 4. And so my average rate of change from 5 to 9 is 28. Okay, what do you think? Okay so far? All right, let's try another one. Now we have a function of 2s squared plus 6. And that describes the height of a bouncy ball after it's been dropped to the ground. Okay, so you know how they go up and down real fast? Okay, we want to find the average rate of change over the following intervals, okay? Because that's going to describe the speed that the bouncy ball is moving. What happens when you first drop a bouncy ball compared to the second time it bounces? Yeah, it doesn't bounce as high, right? So wouldn't we expect like the first rate of change to be a lot higher than the second one? Okay, so let's see if it happens. Calculator or equation? Personally, I think the calculator is a lot easier because then I don't have to, I can just look at my table. Okay, so if I go to my y2, let's clear out our last equation and put in the new equation. Now, it says s squared. What should I just put there? Yeah, just put your x plus 6. My graph's not working. Okay, so we're in there. Now I want to look at my table, so I'm going to hit alpha graph. And I'm looking at the interval from 0 to 2. So at 0, my y is a 6. And at 2, my y is a 14. So my average rate of change is going to be 14 minus 6 over 2 minus 0, which is going to give me 8 over 2, which gives me an average rate of change of 4. All right, let's try the next one from 1 to 4. So that means my formula I'm looking for is going to be the f of 4 minus the f of 1 over 4 minus 1. That's my slope formula basically, right? And looking at my handy dandy calculator, at 4, my f of 4 is 38. My f of 1 is 8 over 4 minus 1, which is going to give me 30 divided by 3, which is 10. Yeah.
Remember to like disable all of them and say 6. That's all it has for me.
Go to your y equal button. Do you have 2x squared plus 6 entered in right?
X.
Yeah, you have to use, don't use the letter, use your X button. Otherwise it doesn't recognize it as a variable. The letters are more for naming and writing stuff. Okay? So is the movement going to produce a straight line? If I have a slope of 4 and a slope of 10 at 2 different points on the graph, is it going to be a straight line? What do you think? Well, let's think about what we have. So, from 0 to 2, I have a slope of 4. So, that would be about here, right? Then from 1 to 4, so like from this point to this point, I have a slope of 10. It's going to go way up higher. So that means that, am I going to produce a straight line? No, because I don't have a constant rate at each interval. Good. Let's look at it on the graph. If mine will graph. Come on. Got it in there. I don't know why my graph's not working right. Let's try. And there's y equals x, so that's working. 2x squared plus 6. Oh, there we go. All right. So obviously, it's not a constant rate of change. Good? All right. We can do, basically, if you're given a table, you're going to do the exact same thing as what you did when you had a table in the graph. Okay? You're just going to use your table functions. All right? So, if I want the interval of 5 to 19, that's like saying I want to find the f of 19 minus the f of 5 and it's all going to be over 19 minus 5. Because that's my y and that's my x's, right? So what's the f of 19? Hmm? 22. Here's my 19. What y is going with it? 22. And what about the f of 5? I got an f of 5, which gives me 1 all over 19 minus 5. So that gives me 21 divided by 14. Can I reduce that down? Oh. What can I reduce it to? Can't remember. What's a good way to check? How about just 21 divided by 14? I don't want a decimal, so I'm going to hit math and fraction. Oh, 3/2. All right, now let's find it over the interval of 11 to 45, because if it has a slope of 3/2 or an average rate of change of 3/2, then we're going to know it's a linear function just by looking at the table. So to find the f of 45 minus the f of 11, and that's all over 45 minus 11. Actually, let's use a different color. Okay, well, what's the f of 45? Going to be 61. And then the f of 11 is going to be 10. Okay, so what's 61 minus 10? That's 51. 45 minus 11 is going to be 34. Can I reduce that down? 51 divided by 34. Put that into a fraction. Hey, look, I get 3/2. So if from this interval the slope's 3/2 and this interval the slope's 3/2, is it linear? Yeah. And I can tell because the average rate of change is constant or the same. How do you feel about those? Isaac?
So if the average rate of changes are different, does that mean there'll never be a...
Then it's not linear, correct. Like when we were doing the one up here, I had an average rate of change of 4 from 0 to 2 and 10 from 1 to 4. Since they're different rates of change, it can't be linear. Okay? But down here, over different intervals, I had the same rate of change. That's going to make it linear.
Better if you have the ABs flapping up.
No, as long as you flip them on both top and bottom. Okay? Okay? Great questions. Any more? Feeling okay about this?